Okay, 112.3 exercises, and we'll start with problem number 1. Certainly, I know there's a blue area there. Certainly, if you look through that in your center, that's great. If you did it on your own without looking at that, that's great. I'm going to go to the whiteboard and write it down now. And whoops, that's not the whiteboard. I'm going to write down what they want. Certainly, this number 1, they want to find the sum of the first n terms and determine whether the series is convergent or divergent. Right, so I'm going to write down Sn, and this is going to be the nth partial sum. And that's going to be what? Well, let's write this down. It's 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7. Notice I put a dot, dot, dot down now. And I'm going to say, if it was going to go the nth term, right, it's a little difficult. I'll be honest with you. What do you mean by that? You're looking at this over here. It's 1, 3, 5, right? And I want to start talking about, where is it ending, right? It's going up by 2, so it has something to do with 2n, all right? It's going up by 2. Now, if I want a1, right, the first term to be 1, this would have to be minus 1. So I'm going to write this over here, 2n minus 1. All right, now before I say anything about what the next factor is, I want to see if this is true. If I took n to be 1, would I get this 1? And this is a1 over here. Now, if I took a2, would I get this term over here? That means n is 2, by the way. Well, let's see. 2 times 2 is 4 minus 1. Yeah, it works good, right? So this would be a3. What do you plug in 3? You get 2 times 3 is 6. Yeah, that's 5. 6 minus 1 is 5. So it seems to work out pretty good. So I'm going to say this is the first factor on the bottom. Now let's look at the other guy. And that's also going up by 2. So that's something to do with 2n. All right? Whoops, I didn't mean to do that. So let me get my eraser out. And we're looking at the second term now. We're going to try to get that. It's going up by 2, by the way. So 2n, and remember, a1, so it's going to be plus 1. The 2 would give me a 5. 2 times 2 is 4, plus 1 is 5. The 3 would give me 7. So it appears this ending guy, factor-wise, is 2n plus 1. All right? And this is what Sn is. Let me get my eraser out. Erase this over here. And this is probably the worst thing you have to deal with, is just what we have written over here. All right, so then the question becomes is, I hope you see a pattern to this, right? And certainly the pattern we just talked about, but I'm going to take the an term, right? Write that down for you. I'm going to split into 2 terms. And we're going to do partial fractions. I'm going to put, this is 1 over 2n minus 1, 2n plus 1. And I'm going to say, gee, I don't know. 2n minus 1 plus b over 2n plus 1. I'm going to multiply both sides by the LCD. I want to get the concept over here that this can be split into 2 terms. And every term can be split into 2 terms then. All right, let's take a look at this. What do you get over here? I'm going to multiply both sides by the LCD. You would get 1 equals a, 2n plus 1 plus b, 2n minus 1. Well, I want to stick with easy n. And the first thing I'm going to pick here, I'm going to pick n to be a half. This would be 1. And then what you get? You get 2a. And what would you get for the b? You get no b's, because 2 times half is 1, and 1 minus 1 is none. So what does that tell me a is? A is a half. Let's see if we get b. Well, to get b, I'm going to pick n to be minus 1/2. What do you get here? 1 equals, well, then the a disappears because 2 times half is minus 1, and minus 1 plus 1 is none. And what do you get here for the b? What coefficient you get? That would be minus 2, right? So the b would be minus 1/2. All right? So I'm going to write that down for you. I'm going to put this over here. over here. And let me write that down for you. This is minus 1/2, and this is 1/2. I'm going to further simplify this by getting a minus sign, say it's a subtraction problem now. I'm going to factor the half out. That's going to be 1/2 times 1 over 2n minus 1 minus 1 over 2n plus 1. All right? Now granted, a lot of work to get there, and someone says, am I done? You're not done, you're just starting it. So let me just erase this over here. I'm kind of done with all that stuff over there. I'm done with my preliminary work, and I want to make sure you know that this is an. So let's write this down. Sn is equal, well, I hope you realize it's 1/2. I'm doing this first term here now. All right, let's write this down. By the way, 1/2 is here. Every term's got 1/2 in it now. And what would I get? And I'll be very careful to write this down. It's 1 over, well, if n is 1, you get 2 minus 1, which is 1. Minus 1 over, that would be 2 plus 1, which is 3. All right, I'm going to put the next term down. I'm going to put this one. This is A2 now. What do you get? Let's see. If it's 2, 2 times 2 is 4. 4 minus 1 is 3. Minus, well, again, I'm looking at the general, and that's going to be 2 times 2 is 4. That's going to be 5. All right, I'm going to keep writing them down, and I'm starting to realize it's a pretty simplistic pattern. But like with any simplistic pattern, I got to write them down to make sure I understand it. 1 over 1, I'm just doing the first term. 1 over 1, 1 over 3, 1 over 5. If you look at the second term of those groupings, it'll be 1/3, 1/5, 1/7, plus 1/7 minus 1/9. Yada, 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 yada. And I'm going to write down the last 3 terms. All right? Let's see if we can do that. So what do you get over here? You get 1 over 2n minus 1 minus 1 over 2n plus 1. Minus, minus. And let's take a look and see what we get over here. And I want to point out, looking at it, you know, if I go forward, the bottoms are going up by 2. If I go backwards, you're going down by 2. And again, if I go backwards, it's going down by 2. All right, this was known as a telescoping series. So what I want to do is I want to tell you why it's telescoping. And I'm going to look for cancellations now. I'm not saying it's going to be easy for you. But I hope you start to realize that this thing cancels this, this cancels this, this cancels this, this cancels this. There's someone before him that cancels that, cancels, 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 cancels. All right, so what are you left off with? Let's write this down now. This can be equal to 1/2. You get 1 over 1. That's here. Minus this thing. It's the only thing that's left. A lot of things have disappeared, right? All right, and this is Sn. What does Sn stand for? The nth partial sum. An is the nth term. Sn is the nth partial sum. Okay, what are we doing now? This is the nth partial sum. So Sn is 1/2. 1 minus 1 over 2n plus 1. We'll look at the key later. Now what they want to do is they want to take a look at what's S infinity. In other words, infinite number of terms. Well, what you're going to do is the limit as n goes towards infinity of Sn. What's that going to be? The limit as n goes towards infinity. Well, what's Sn? It's 1/2, 1 minus 1, 2n plus 1. What happens here? Well, if you look at it, the term 1 over 2n plus 1, the bottom blows up without bound, so that goes towards 0. You left off 1/2 times 1, which is 1/2. That's the infinite sum, right? All right, let's take a look at the key, see how we did. This is me talking through it. Let's say, did I get Sn? They wrote it a little bit differently, so I'm going to write down a little differently now. This is 1/2, and we'll get to what they wrote down in a second. This is 2n plus 1, 2n plus 1 minus 1, which is going to be 1/2, 2n, 2n plus 1, which is going to be n over 2n plus 1. That's what they have written down. Now, by the way, don't think you have to write that way. It's really the same thing. Each one of those statements is the same. Did they get the limit as n goes to infinity? Of course, they did 1/2. Telescoping series. Thank you.